But if you haven't put your Penn State email into the chat box for me, that would be awesome. And we will just use that for our, attendance log and whatevies. So yeah, let's do this chapter. So like I said, pretty short. We've been talking about hypothesis tests and whatnot in general, but this is talking about a specific type of hypothesis test that has a different test statistic than we've been talking about, and just kind of a different way of thinking of hypothesis testing. So ANOVA is technically a one-way analysis of variance. It's kind of what it stands for. So nothing too crazy there yet. All right, so people often ask, when we say we're going to do an ANOVA test, why wouldn't we just do a bunch of t-tests? So if we were going to do a bunch of t-tests, we would need a lot of them in order to get the information that we could get out of an ANOVA test. So that would just increase the chance of getting a type 1 error, which, remember, a type 1 error is going to be the incorrect rejection of a true null hypothesis, also known as a false positive. So if we would reject the null when the null is actually true. And that's basically what the idea of that is. It would increase that chance of a type 1 error, and the next bullet could inflate alpha. Remember, alpha is also our chance of getting a type 1 error. So, if we did that and took a bunch of t-tests, our alpha would continue to grow. So that wouldn't really give us a lot of good information, and then, overall we would not have a lot of information about that independent variable. So kind of not useful, honestly, to use a bunch of t-tests. That's why ANOVA tests have come into play. And just as a review, as we always do, what our different 5-step hypothesis testing procedures are. So first, we're going to check those assumptions and write our null and alternative hypotheses. Second, we're going to calculate that test statistic, which for ANOVA is a little bit different than what we've been doing for proportions and means. And then thirdly, calculate that p-value associated with the test statistic. And lastly, 4 and 5, just make that decision between your null and alternative, and then continuing on to state that real-world conclusion. So that's the main idea there with our hypothesis testing. This is just, like I said, the standard 5 steps that we use. But now we'll go through them one by one in terms of what an ANOVA test is. So our first one is that so we have to check our assumptions first, remember, and then write our null and alternative. So our first one is that we have to make sure that we have like 3 assumptions specifically for ANOVA. So they have to be independent random samples. They have to follow a normal distribution, and then lastly, the population variances have to be equal across the responses for the group levels there. So and then that note at the bottom there, this is just kind of a rule of thumb that you use in ANOVA tests. So if the largest sample standard deviation divided by the smallest sample standard deviation is not greater than 2, then you can assume that this third assumption is met. So, because a lot of times it's like, if you don't have all the population variances, how are you supposed to be able to tell if they're equal across the group levels? But if you're given the smallest and largest standard deviation, you can find that out as long as those aren't greater than 2. So those are the 3 assumptions that have to be met, and then basically our null and alternative hypotheses here is just going to be that basically our null is that all of the means are equal to each other, and then our alternative is that not all of them are equal, so at least one of them is different in that case. So yeah, that's our first step. And then second, like we've been talking about, that our test statistic is a little bit different for this week. For ANOVA, we do have a test statistic F, which we'll find from Minitab. You'll either be, provided this in a Minitab output. It's the same idea. It's still our test statistic that we use, similar to our T and our Z, but for ANOVA, we do use a F value here. And then, that our p-value that's associated with it will be right next to it, which is what we use in our third part. So we want to make sure we find out that p-value. And then that's based upon what our test statistic here was, the F value. And then based upon that p-value, you make this decision between the null and alternative hypothesis. So are you going to reject the null, fail to reject? And then depending on what decision you made here, you're going to just state that real world conclusion and say, what do we think is, what are we inferring based upon the original research question? So kind of going forth and saying, what do we think is the actual thing going on here in terms of the actual variables that we're talking about, not just numbers. So yeah, and also something to keep in mind too are with our test statistic being F, and in ANOVA we do have a right tail probability. That's just something to keep in mind in general. We talk about that too in like chi-square tests, but so yeah, it's a right tail probability in this case. Just something to remember. Okay, and then so the post-hoc tests, and then specifically Tucky's is basically all this is talking about is what you would do after your ANOVA test. So you get, you know, your conclusion. You say you think that the variables are different from one another. What this post-hoc test it does is basically tell you which groups exactly are different from one another. You know, so you can do this in Minitab or whatever, but it's basically telling you, it's kind of being more specific. So, you know, your hypothesis test tells you, you know, a general conclusion like the groups are different from one another or they're not. And if you say that they are different from one another, then you can go ahead on and do this post-hoc test, and that'll specifically tell you which groups are different from one another to be a little bit more specific there. All right, yeah, I told you this is a really short chapter. It's literally just one hypothesis test. So, so let's do some reviews. And then obviously if you have any other questions, we can go over that. So my first one says that we have two sets of sample data, A and B, are given. Without doing any calculations, indicate which set of sample data, A or B, there's likely to be a stronger evidence of a difference in the two population means. So go ahead and look at these data sets and let me know what you think the answer would be. Okay, good job. Yeah, so our answer here is going to be A. You guys are right, as per usual. So in this case, we're talking about if there's likely to be a stronger evidence of a difference. So if we look, you know, in our data set B, we have some sort of overlap going on, you know, between these parts. There's overlap in the graphs, but in data set A, there's literally no overlap going on. So that means that we are pretty confident that there's not any sort of like common ground between the two. So that means that we're probably going to have, you know, we have strong evidence saying that there is a difference. Like, you know, we have over here in our, for data set B that, you know, this could be different from this and whatnot, but then we have all this center stuff that's saying it could be the same. So data set A is going to give us better evidence that there will be a difference between the two population means, because basically there's nothing in common between them, which is giving us that strong evidence. So data set A is the correct answer. Good job. All right. All right. 90 people with high cholesterol are randomly divided into 3 groups of 30, and a different treatment program for a decrease in cholesterol is assigned to each group. The response variable is a change in cholesterol level after 2 months of treatment. An analysis of variance will be used to compare the 3 treatments. What null hypothesis is tested by this ANOVA F test? So this has to do with our first step of doing this hypothesis testing procedure that I just showed you guys. To try to answer this one, we will go over it. All right, good job, guys. Yeah, so remember, when we're talking about our different hypotheses testing and our null and alternative hypotheses, we're always talking about our population. So we can cancel out C and A immediately because they're talking about the sample variances and the sample means, which is not, we're always talking about population. So we know that those can't be true. But then remember, in terms of our alternative hypothesis for these tests, we would always do something that we want to see that they're all equal to each other, in this case. So in this case, we're talking about population means, not variances. For an ANOVA F test, our answer is going to be D here, so you guys are correct, because we're talking about the population means all being the same, not variances. Variances have to do with like assumptions, but not actually writing out the null hypothesis test. So our answer would be D there. So good job. All right, I feel like we only have one more. All right, so given the mini-tab express output above at the 0.05 alpha level, which pairs of summer sports are significantly different? People struggle with this one a little bit, I remember last semester, so try this one out and then we will go over it. Okay, good job. So yeah, our answer here is C. You guys are doing great, as always. So in this case, we're talking about them being significantly different. So where did you see here? So in this case, swimming and volleyball don't share a grouping letter. So, the rest of them do share something, like running and swimming share a grouping letter, running and volleyball share one, but swimming and volleyball are two that do not share a grouping letter. So in that case, so that's talking about them being different, obviously. And then, so at that significant, and then also, if we look at the p-value for the pairwise comparison here, then you're able to see that it's like the smallest one in that case. So basically, in that, we want to decide that the smallest, remember our smallest p-value is going to be the one that's the lowest. That's going to be the one that's going to give us the most evidence in terms of rejecting that null. So C, volleyball and swimming are going to be the ones that are significantly different because those ones do not share anything. Similar to those graphs that we looked at that don't share anything, that's going to give us more evidence that they do, that they are different from one another. So, but yeah, okay, cool. So that's our answer. Good job. You guys are killing it. So yeah, that's what we got for tonight. Super short, I know. But go ahead and, obviously check out the YouTube channel if you're feeling like some, need something fun to watch, get tired of SpongeBob, looking for some fun. So watch the YouTube channel. Our next group review will be on Sunday at 10 o'clock. If you haven't already given me your Penn State email, go ahead and type that into the chat box for me. And if you have any other questions, let me know. If not, you guys are good for tonight and have a good weekend.